Welcome Mathemaniacs, and we're back for more Edumacation. Today's topic is on the four arithmetic operations: addition, subtraction, multiplication, and division. So we always think about these four, and we have all kinds of different ways in algebra that we can kind of combine them, and we expand to more operations eventually. But I want to let you know a little bit of a kind of a secret. It turns out that all four operations, we talk about four, but there's really only one. That's addition. All of these four operations that we deal with, that describe all kinds of different situations, are really just addition.
But all the operations are really addition. How does that work?
Well, I'm glad you asked, Billy. We are going to go through them one at a time and show you how each one kind of fits in.
I mean, come on. There's no way you can say that subtraction is addition. I mean, they're complete opposites.
True, subtraction is the opposite of addition, but that actually is what makes it most similar. The fact that we have inverse operations, these operations undo each other. This is one that's addressed in algebra itself when we talk about subtraction being adding negative numbers.
Here's an example of a traditionally modeled subtraction problem. We can use money as an example. We have $10 minus $7 equals $3. If I have 10, I simply take away 7, and I have 3. So numerically, we can see over here, 10 minus 7 is 3. Here's what it would look like if we change this to an addition problem. Here we can see this example using debt. I start off with $10 as before, and I now have 7 IOUs of $1 each. In having these IOUs, I don't possess money, but I owe money. So I have to, in order to resolve these, I actually have to take away from my $10, thus giving me $3 left over. I'm still adding something, but that something is negative. And so over here, we represent numerically with negative numbers. 10 plus negative 7 equals 3, just like we have above. Okay, well, I guess I can give you that one, but multiplication, totally different from addition.
Yeah, well, multiplication is actually a pretty simple one as well. It's simply repeated addition. We're adding the same number multiple times, as we can see here.
We can model a multiplication problem using addition by the idea of groups. Here, I have 3 bags. Each of them has 5 marbles in them. 5 red in this one, 5 green in this one, and 5 blue in this one. The way that I would normally work out this problem with multiplication is I simply take my number of bags and multiply it by the number of marbles in each bag. 3 times 5, which gives us 15. However, we can use repeated addition for this. If I have 5 marbles in each bag, I simply have to take the number of 5s that I have bags and add those together. In this case, 3. 3 5s. Add them together. Gives me 15. It's important to note as well that I could switch these two numbers around interchangeably. If I had 5 bags with 3 marbles in each bag, that would also be 15. And I could simply model it this way. Okay, I guess you got me there. But division, there, that'll have you stumped. There's no way you can tell me that division is anything like addition.
True, division is the trickiest one to kind of picture, but I hope to show you how it too is simply addition, just in another form.
To understand how we can interpret division as addition, let's review what we've seen so far. We know that subtraction is the inverse of addition. They undo each other. We also know that multiplication is repeated addition. So how does division fit into this diagram? Well, we know that division and multiplication are inverses, just like addition and subtraction are. So if we were to try to fill in this diagram, division would go down here. And if we look at this association, then it would make sense that division is simply repeated subtraction. And that gives our answer for how addition relates to division. Here's a model for our division problem. In this case, it's very similar to our multiplication model, and for good reason. Because they're inverses, we simply turn the problem around. Before, we knew how many bags we had and how many marbles were in each bag. And we're trying to find the number of marbles we had in total. Now, we know how many bags we have, and we know how many marbles we have in total. And we know that each bag contains the same number of marbles, but we don't know what that number is. How could we use addition to figure this out? Well, here's how. We start with our total number, 15. Now what I'm going to do is I take one marble out of each bag and pull it from the total. It's like subtracting. However, because I want this to be addition, we're going to use adding negative numbers. So I took away one marble from each bag, which is 3. So 15 plus negative 3, well, that's 12. Now I still have marbles left, so I'm going to do the same thing again. One marble from each bag. Now 12 minus another 3 is 9. I still have marbles left. So I'm going to continue doing this until I either have no marbles or I have too few marbles to take away a whole 3. What was 9 became, when I took away another 3, became 6. When I took away another 3, I had only 3 left. And when I took away the last 3 marbles, one from each bag, I ended up with none left. So how can we use this model for division? Well, all I have to do is count the number of times I took away 3. I have 1, 2, 3, 4, 5. I took away 3 5 times. That means there had to be 5 marbles in each bag when I started. To further show how division is simply repeated inverse addition, I'm going to do this long division problem using the language you've probably heard. And then I'm going to do it again using subtraction. Here's how. First, I know that 4 does not fit into 1, but it does fit into 15. It fits in 3 times. 3 times 4 is 12. When I subtract 12, I get, from 15, I get 3 left over. I bring down my 6. Now 4 fits into 36 9 times, or I should say, 9 times. There you go. 9 times 4 is 36, exactly, which gives us nothing left over. Now, let's rewrite this using these numbers as a subtraction problem with a few adjustments. Here, where did these numbers come from? Well, this number is the number I started off with. This number is the number I had left over when I was done, my remainder. These two numbers emerged from the actual long division. 36 is right here. 120 is right here. You might think, well, that's 12, but you're forgetting that we have an implicit 0 here. So hence the 120. Well, let's do some factoring. I bring down my 156 and my 0. This number is simply 4, or rather negative 4, times 30. This number is simply negative 4 times 9. So 30 groups of negative 4 and 9 groups of negative 4. When I combine these, I end up with 39 groups of negative 4. And this would be the same as if I took 156 and subtracted 4 39 times until I got 0. And 0. There's 39 negative 4s. Obviously, this is a little bit cumbersome, but it is a demonstration of how you would do it if you wanted to use addition for division.
Thank you all for watching this video. Hope it was informative. Billy, take us out.
Want more education? Subscribe to the official Math Edumacator YouTube channel and follow us on Twitter at Math Edumacator. See you next time. Oh, and have a totally radical day.